Hello class, good afternoon. How's it going? So here's the YouTube video I promised you. I'm not too good at this yet, so you have to bear with some of my imperfections. But anyways, we didn't have much time in class today, so I wanted to talk about how to solve some of these equations. Yesterday we talked about simplifying expressions, but now we want to talk about solving some equations. So in other words, when there's equal signs, we want to figure out what x is. We want to figure out what angles we can plug into this equation that'll be solutions, where the left side equals the right side. Okay, so we're going to be using all those properties that we talked about yesterday of these trig functions, the identities. Okay, so remember tip number 1 I told you is look out for chances to use the Pythagorean identity. Okay, so the Pythagorean identities, so I see cosine cubed, so maybe I'd think cosine squared plus sine squared equals 1, but that one's going to lead us a little bit empty there. So we're not going to go that way. Tip number 2 is turn everything to cosines and sines. Okay, so I'm going to do that. The left side of the equation doesn't change. Okay, so here's the left side of the equation. Cosine cubed x over sine x equals cosine x over x. Over sine x, because that's what cotangent is. Okay, so we just rewrote cotangent in terms of sine and cosine. All right, so something jumps out at me here. They both have sine x as a denominator. So I can multiply both sides by sine x. Or in other words, these cancel out. So I'm going to have cosine cubed x equals cosine x. All right, another thing you might want to do here, which I want to warn you about a little bit, is we want to say, all right, a cosine x on both sides, so let's divide both sides by cosine x. But think of a problem like this. X squared equals x. All right, so let's think about what happens if we divide both sides by x. We're going to end up with x equals 1, right? And yeah, sure, that's a solution. If we plug that in, 1 squared equals 1. Yeah, true story. Okay, so that is a solution, but there's another solution that we're missing. Maybe you recognize it, maybe you don't, but x equals 0. What about 0 squared? Doesn't 0 squared equal 0? You betcha, it sure does. Okay, so the real way to get all the solutions is we don't want to divide by a variable. Instead, we want to bring it over, and then we want to factor. Okay, so we'll have x squared minus x equals 0. Factor out a greatest common factor. And now we can see that's where the x equals 0 comes from, and we still get the x equals 1. Okay, so with this idea over here, we want to translate that over here to what we're doing with cosines. Okay, so we want to bring that cosine x over to the left side of the equation by subtracting cosine x from both sides. Now we want to factor. Hopefully you guys can follow that. And now that we are factored, well, there's a few things to do. One thing here is I'm having a Pythagorean identity jump out at me here. This problem is doable without that, and we'll talk about it tomorrow. But since we're practicing all the identities, I'm going to go ahead and use that. All right, so the identity with cosine squared in it is sine squared plus cosine squared equals 1. So I want to try to make this over here match this. So I have to make cosine squared minus 1. So I'm going to subtract 1 from both sides, bring that over here, and subtract sine x from both sides. So I'm going to have cosine squared x minus 1 equals negative sine squared x. All right, so I manipulated this identity, which is always true, so that it matches what's in the parentheses here. So cosine squared x minus 1, I can replace with negative sine x squared. So cosine x times negative sine squared x equals 0. So now I can set both of these equal to 0. Cosine x equals 0 and negative sine squared x equals 0. We'll talk about this one in a second, but let's do a little bit of work here. Let's divide by negative 1, and then let's take a square root. So anyways, sine x equals 0, right? So these are the two simpler equations. We started with one really complicated equation, and now we have two simpler equations. I'm boxing those, but they're not our final answer. Remember, we want to figure out what x is, what possible angles. We want to solve for the variables. Okay, so what angles we can plug in to get solutions. And hopefully remember from the test we just took, there's going to be an infinite number of solutions. We just have to find which ones actually fall into that category of infinite solutions. All right, so here we got to go back to our trig circle, the unit circle, and we want to figure out where does the x-coordinate, remember cosine is the x-coordinate, where is the x-coordinate 0? And hopefully you can recognize it's going to be those two angles, and any angles coterminal with those angles. So we're going to have pi over 2 at the top, and 3 pi over 2 at the bottom. And we want all the angles that are coterminal with those two angles, so we can keep adding a full circle. So we can add 2 pi, 4 pi, 6 pi, 8 pi, any even multiple of pi. And so that's where that k comes in. So we can add 2 pi however many times as long as k is an integer. And we can do that here as well. All right, now let's think about the other equation, because it's also going to have some solutions. So we want to think about the unit circle again, and we want to know where the y-coordinate is 0. All right, the y-coordinate is going to be 0 here and here. All right, so that's going to be at x equals 0 for here, and x equals pi over here. And once again, we want to consider all of the coterminal angles. So we keep adding 2 pi k number of times, as long as k is an integer. So we can add 2 pi, 4 pi, 6 pi, 8 pi. All of those angles are still solutions. Okay, so that is how we would do a problem like this. So it's a really tough problem, really complicated up here, and we use some identities, but then eventually after using some algebra skills and our use of identities, we get down to some simpler equations. All right, not that any of this is easy at all, it's all really difficult, but that's what we're going for. And tomorrow we'll talk about how we can actually write all this mess as just this, pi over 2 plus pi k, and this whole mess right here we can just write as x equals pi k. All right, but we'll talk more about that tomorrow. Appreciate you listening. Have a good one. See ya.